So today we are going to talk about iron metabolism, normal iron metabolism first, and then iron deficiency states and especially iron deficiency anemia. Is that right? So discuss about the iron metabolism, normal iron metabolism. I will just draw first of all GIT and show the absorption of iron. Right? Let's suppose here is your gastrointestinal tract, GIT. Here I will draw, iron is mainly absorbed from the duodenum, right? So I will make one duodenal cell, a large duodenal cell, in which I will show you how the iron is absorbed, right? So iron will come from the GIT as a part of the food. From the duodenal cell it will be absorbed. We will go into detail of every step. Then it will come to the blood. Is that right? So here is your circulatory system, and iron need to be transported to the blood. Is that right? And then other important parameters which are very important while discussing the iron metabolism is that once iron has been taken into food, absorbed from the duodenum, come into circulation, then it is transported in the circulation to the places where it is stored or where it is utilized. Either the iron which is coming, it will be stored in the body for the future use, or it will be utilized directly, right? So major utilization of iron is in the hematopoiesis, right? That is about the bone marrow house, where hematopoiesis is going on. There is a major use of iron, right? You must be knowing that normally iron is present in which part of the body? Right now, how much iron you have in your body? Total body iron. Total body iron. Yes. In a healthy adult person, normally total body iron is somewhere between 2 to 5 grams. But you have to remember that many women who are in the child reproductive age, the women who are in reproductive age and either they are menstruating monthly or they are having repeated pregnancies and lactation, right? Under all these circumstances, right, demand on the iron is more. Is that right? And many women may not have iron in stored form. Even some countries like first world USA, they say every 6th woman does not have iron stores. Is that right? So iron stores are sometimes totally absent in adult healthy women without any anemia, right? They are just having the very precarious or delicate balance of the iron. Now I was talking about that iron is taken from the food, it is absorbed from the duodenum or upper GIT, small gut, come into blood. From circulatory system, it will be taken where it should be utilized or it should be stored. When we talk about utilization of the iron, iron is present in our body in which form? Basically, iron is in two forms present in our body. Yes. Number one is functional form of iron. Functional form of iron. Number two is storage form of iron. Storage form of iron. The iron which is present in your body, either it is functionally active right now or some of it may be stored. The functional iron is present in just hemoglobin. 80% of the functional iron is present in, or 70% of the functional iron is present in hemoglobin, right? And about 5% of the functional iron is present in myoglobin. 5% of the Functional iron is present in myoglobin. Then there are enzymes in our body, different enzymes which also require iron. For example, there are cytochromes and their catalases, right? They also have iron. So what we can say, the iron which is present in our body in a functional form, again you have to remember, out of the total iron present in your body, the total iron which is present in your body, 80% is in functional form and about 15 to 20% is storage iron, right? Functionally active iron, which is really doing some physiological functions, is present in hemoglobin. In the hemoglobin, in the heme component, iron is present there, which help in transport of oxygen. Then iron is also present in myoglobin, which is present in the muscles, that also binds oxygen. Then iron is present in some enzymes like cytochromes and catalases. And you know, cytochromes are very important as a part of electron transport chain in mitochondria. So every cell with mitochondria needs iron, because every cell which has mitochondria must have cytochrome enzymes. Is that right? So it's a very poor idea that iron is only required for hemoglobin and myoglobin. You must remember, every cell with mitochondria require iron for its cytochrome. Is that right? Then storage iron is present in two forms. Storage iron is present in two forms, right? One is ferritin. I will explain into detail what is ferritin. And other storage form is hemosiderin. Now, as good doctor, you must know the difference in ferritin and hemosiderin. Both of them are storage form. So what are the differences in them? We'll discuss into detail later, right? So up to now, what we have discussed, that in a healthy adult, the total amount of iron in the body may be about 3 grams to 5 grams, or 2 grams to 5 grams. Women have relatively less. The women in the reproductive age, due to menstruation, due to pregnancy, or due to lactation, all these situations, in menstrual there are losses of iron, RBCs, of course, along with the hemoglobin and iron, and in pregnancy and in lactation there are more demands on the iron. So the females who are in child bearing age or in the reproductive age, they have more demands on the iron, so they have less stores of the iron. Is that right? So, and in normal person, about 80% of the iron is present in functionally active form, and 15 to 20% is present in storage form, right? And functional is hemoglobin and myoglobin. Hemoglobin make again most of the iron, then some iron is myoglobin, and very little amount of iron is part of the cytochromes and catalases. And storage form is present as ferritin and hemosiderin. 2/3 of iron stores are at ferritin, and normally 1/3 of iron stores are as hemosiderin. But again, it's not enough just to know there is ferritin and hemosiderin. We must know what are the real delicate differences in these two. We'll talk about that, right? So let's go back and talk into detail. So iron is coming from the food, from the duodenum it is going to the blood. Through the blood it can be transported in the areas where it is being utilized. So it can be utilized in formation of hemoglobin, in formation of myoglobin, formation of cytochromes and catalases. Is that right? But I will discuss today's lecture mainly the utilization of iron and formation of hemoglobin, right? Then along with that, there are storage of the iron. Most of the iron is stored in the macrophages. Is that right? Macrophages which are present in the bone marrow, macrophages which are present in the liver, and macrophages which are present in the spleen. So I will make a big macrophage here, which is representing the iron storage system. This is a big macrophage. Where it may be in the liver, or it may be present in spleen, or it may be present in bone marrow, right? So this macrophage here, I will show you in the diagram the storage form of iron. And then of course, liver is also playing a role in iron metabolism, because some of the iron is stored in hepatocytes also normally, right? So let's start with the very beginning, from where we are getting the iron and how we are getting the iron into our body. Basically, iron is provided in the diet in two forms. Iron in the diet, which is as a part of meat, when you are eating the animal products. You are having meat, or you are eating liver, of course cooked, or when you are eating eggs or egg yolk, right? So these have iron. So we can say iron may be present in animal products. Is that right? Animal products, right? In which especially meat muscle, and liver, egg yolk, and others. Plus, now this iron, which is present in the animal product, it is part of the heme. You know, animals, of course you are eating animal muscles, right? And in the animal muscles, there is also myoglobin, and if some blood is also there, of course cooked. So, heme, right? So this iron is coming in which form? Heme form. This iron which is coming from the animal product, this is which iron? Heme iron. Is that right? Then iron is also present in our diet from vegetables and other sources which are not from the animals, right? So from vegetables and fruits, right? Iron is present, but this iron is not heme form. This iron is not heme form. We simply call it inorganic iron. What we call it? Inorganic iron. So basically, we are getting two types of iron in our diet. There is inorganic iron, and yes, there is heme iron. Now here it's very important to know that for our body purpose, heme iron is a superior type of iron. It is a superior type of iron, and inorganic iron is inferior type of iron. Why? Because, for example, if you have 10 milligram of heme iron and you have 10 milligram of what? Inorganic iron, both are in equal, the content of iron may be equal in both. But heme iron is absorbed better. Heme iron is absorbed better, but non-heme or inorganic iron is absorbed poorly. For example, out of heme iron, 10 to 20% is absorbed. Out of heme iron, 10 to 20% of the heme iron can be absorbed, right? But in inorganic iron, only 1 to 2% can be really absorbed. So we can say that it's not enough to know that how much iron is going. It's also very important to know what type of iron is going to your GIT. Is it organic form of iron or heme iron, or is it inorganic iron? Because heme iron has more ratio of absorption. It means it is more bioavailable. So term we will use that heme iron has better bioavailability, and inorganic iron is having poor bioavailability. Why it is so important to stress on this? The reason being that in poor countries, number one, in their diet, total content of iron is less. In poor countries, right? Number one, because food is not so abundant in the third world. So overall iron or food there which they are taking, that is less. And number two, their food is more vegetables and less meat. So number one, total iron is less. Secondly, the type of iron they are taking, that is inferior. So heme iron is superior iron and inorganic iron is inferior iron, right? Now, once iron is going in, right, from the stomach, once it goes to the duodenum, here of course proteins are partially digested, right? And there are special heme iron transporters here in the duodenal cells. It's a cell of the duodenal mucosa. This is its apical side. It is its basolateral side. So absorption will come from apical side. So these cells will import the iron from the apical side and export the iron to the blood from basolateral side. Now what really happens in the heme, there are special heme iron transporters here, right? So iron will transport from here in. Is that right? So iron will come in. Once the iron has come in, heme iron has entered in, right? What is further fate we'll discuss later. Let's talk about inorganic iron. This inorganic iron, as I told you, it is poorly absorbed. The first thing is that inorganic iron is present in ferric form. It is in ferric form. So it needs to be converted into ferrous. It needs to be converted into ferrous form. For this purpose, there is a special enzyme here, and this enzyme, right, is responsible to convert the ferric iron into ferrous iron. So it is, what should be the name of this enzyme? It is ferrous reductase. It is reducing the ferric into ferrous, right? So first of all, in the duodenal cells, there are ferroreductase enzymes which are expressed on their apical surface of the cells, and they convert the ferric form into ferrous form, because ferrous form is better absorbed as compared to ferric form. After that, here there are very, very special channels, right? There are very special channels, and through these channels, basically metals are absorbed. Through those channels, what really happens, there is absorption of metals. Because these channels are helping in absorption of metals, we call them divalent, because they help in divalent metals. Is that right? Ferrous is divalent and ferric is trivalent. From here, through this channel, divalent ferrous can absorb, but trivalent ferric cannot absorb. Is that right? So what really happens, these are called divalent metal transporter 1. What is this channel called? Divalent metal transporter 1. Right? Now you can understand that it is so important to convert the ferric iron into ferrous form, then it will be better absorbed. Once the iron enters into this cell, what will happen? I told you either there is a heme iron or there is inorganic iron, but once this iron has entered into cell, which iron is more efficiently taken up by cell? Imported by the cell. Cell import the iron from lumen of the GIT to the intracellular environment. Heme iron is more efficiently absorbed and non-heme or inorganic iron is poorly absorbed. Is that right? Now, once the iron is in, then what happens? Who will tell me? Listen. It's very important to know that iron absorption should be very strictly regulated. Body should not be too much overloaded with iron, because in very high amount, iron is very, very toxic. Even though it is required by our body, but in very high amount, iron is very toxic. Later on we'll learn, when body is overloaded with iron stores hemosiderin, and hemosiderin sometimes becomes so much, it starts damaging our tissues. And a pathological condition develops called hemochromatosis. So iron in very high amount is toxic. And even small amount of iron in free form is also toxic. Iron in free form is highly toxic. If iron is present in free form in our blood and in our cells, it will damage. First of all, free iron, it's highly polar compound. it will react with DNA. It will react with DNA. It will damage the DNA. Free iron can react with the lipid membranes. It means it can damage the mitochondria. It can damage the cell membranes. You are understanding? Free iron can react with many components in the cells and release highly dangerous free radicals. Right? So due to this reason, iron absorption should be very well regulated. Right? Now, body does not have any well-defined way to get rid of extra iron, especially males. They don't have any well-defined way to get rid of extra iron. Regularly, males lose a very little iron every day. How much iron adult male lose every day? Only 1 milligram. If we talk about iron losses, then I will come back to absorption. I want to correlate something here. That iron losses are by the human males, that is only about 1 milligram per day. And human females which are in the reproductive age, and you can say menstruating females, they lose more iron because in menstrual blood, iron RBCs are lost. With that, hemoglobin is lost, heme is lost, as of course, as a component of heme, iron is also lost, right? And on average, human females require per day iron which should be absorbed is more than male, that is about 1.5 milligrams per day. Is that right? Now, where the males are losing iron, I think this young friend is going to tell me where the males are losing iron. Of course, everyone knows females are losing iron during reproductive age, especially they lose in the menstrual cycles. And if they get pregnant, then a lot of iron is going to the baby because the baby is making its own hemoglobin and enzymes and myoglobin. Is that right? Or in lactating females, they are losing the iron in milk also. But my question is where the males are losing iron. Who is going to impress me by the answer? No, I'm talking about, look, what I want to tell you that every day we are losing some iron. And that iron should be replaced by the absorption. But normally we lose very little iron, right? Human males, adult males lose about 0.5 to 1 milligram iron per day. Where they are losing iron? Anyone can answer me? Very good. He is concentrating on feces. His answer is right. In the fecal matter, there are a lot of exfoliated, lost GIT cells. You know, GIT cells are constantly proliferating and they are shedding into fecal matter. Every week, lot of your mucosal cells are lost into fecal matter. So basically, human males, they are losing into, number one, lot of iron in exfoliated cells in the GIT mucosa and liver, GIT mucosa, and these exfoliated and lost GIT mucosal cells are present in feces. Fecal loss of iron. Plus, this is the main loss. Very little loss of iron is present in urine and also in sweat. Right? But really, if you want to remember one, it is the fecal loss. I will explain from where that loss comes. But when a lot of mucosal cells of the GIT are shed, in those cells some iron is present and that iron is lost. Adult human females, where they lose the iron? Of course, they lose in these three also. Right? They also lose some iron in fecal matter. They also lose some iron in urine, very little, and in sweat. And the females in reproductive age, they also lose additional iron in menstrual blood. Right? During normal menstruation, how much blood is lost? Anyone can tell me? Yes, you look very intelligent, my friend. In normal menstruation, how much blood is lost per month?
Per month or per day?
Look. When we say per month loss, it means in 1 month, if female is menstruating for 3 days or 4 days or 5 days, mean total blood lost in those menstrual days. 20 ml. Right? That's fairly good idea. Anyone else has different opinion? Yeah, it's a little higher. Yes. What is that?
About 300 milliliters.
Oh my God, you will kill the female. The normal loss should be is usually between 30 to 50 ml per menstrual cycle, right? If it is more than 80 ml, if it is more than 80 ml per cycle, we say there is menorrhagia. Have you heard of menorrhagia? Menorrhagia is a condition in which female is losing excessive blood in menstrual cycle. It is defined as blood lost more than 20 ml per cycle, or bleeding more than 8 days, or blood with clots, because when there's too much blood, it clots. Is that right? So 300 ml will be too much, right, on the pathological side. So about 30 to 50 ml. Now you must know, in 1 ml blood, how much is the iron? 1 milligram. In 1 ml blood, iron is 1 milligram. A female losing about 30 ml blood, 30 milligrams she has lost over 4 or 5 days of her menstrual cycle. But if you spread it over the month, then it will become 1 milligram per day. That is why, as compared to the male, female have extra losses, right? It is 1.5 milligram or up to 2 milligram iron, because 1 milligram female requires the same iron which she is losing in the same way as males are losing. Males lose about 1 milligram iron, half to 1 milligram iron in fecal matter, urine and sweat. Females also lose half to 1 milligram iron in fecal matter, urine and sweat. But females in reproductive age have extra losses of iron in cyclical bleeding of menstruation, and that extra loss of iron can increase the daily requirement of iron to be absorbed. Dietary requirement is different. Iron to be taken in diet is different, and iron to be absorbed is different. I think I must make it clear. For example, as a male, you need every day 1 milligram. But you cannot absorb 1 milligram iron by taking 1 milligram, because usually whatever iron you take, about 10% is absorbed. This is a very important point. That whatever iron you take, if your absorption mechanisms are good, you absorb approximately 10 to 15 milligram iron. 10 to 15%. So it means if you need 1 milligram iron from here to here, it means how much iron you need into system? 10 milligram. Out of 10 milligram, 1 milligram will be absorbed. But this 1 milligram which is coming, where it is required? It is required for compensating for the losses in fecal matter, urine and sweat. And in female, she requires about 1.5 to 2 milligram every day. Is that right? Because of additional losses. And of course, then females require too much iron when they are pregnant. Especially in second trimester and third trimester of pregnancy, the demand of iron required to be absorbed is not just 2 milligram, it is 3, 4 or 5 milligram. In the same way, females which are lactating, they also need more than 2 milligram, 3, 4 or 5 milligram iron. I'm stressing it again and again. Is that right? No problem into this? So this is iron required by the males, and this is the iron required by the females to be absorbed every day.